questions for the audience in Tidak, Pak.
Belum dikasih.
Dimention juga untuk mahasiswa absen online. Nanti saya tampilin QR-nya di situ. Mereka tinggal scan aja. Buat sertifikat.
Ke bahasa Indonesia aja tuh ya kalau itu.
Apa kalau itu?
We would like to express our utmost gratitude to Dean of Faculty of Geological Engineering, Dr. Engineering Boy Yosef, for being with us today. Do another urgent and official engagements where he must kindly leave. He must kindly leave the venue at this moment. Once again, thank you very much, Boy, for your valuable time and presence. Let us give another warm round of applause. Thank you, and may now proceed with the next session of our event.
kita akan menyaksikan nanti sejumlah paparan dari para pakar yang sudah menggeluti bidang ilmu geologi berkaitan nanti dengan topik mekanika teknik. Mungkin agak susah menangkapnya karena kita di geoscience biasanya memandu kepada riset, mengacunya kepada riset geoscientist, tapi ini di mekanika teknik kita mengacu kepada aspek keteknikannya. Nah, ini jadi catatan dari sejumlah topik yang nanti akan diajukan. Ya, Anda boleh browse. Sudah punya flyernya belum? Belum ada ya? Sebentar. Mungkin boleh ditampilkan flyernya. Ini. Boleh Anda foto. Ini ada 4 topik yang saya kira sangat relevan dengan aspek keteknikan kita. Ya, itu bisa jadi catatan bersama. Saya menyoroti 2 alumni kita, Pak Rinaldi dan Pak Syahreza Angkasa. Ya, 2 orang beliau ini ada alumni yang paling kanan. Pak Rinaldi dosen muda di kita dan Pak Syahreza berkarir di BRIN. Nah, saya berharap para mahasiswa peserta nanti sudah menyiapkan keingintahuan. Ya, mungkin dari sekarang Anda bisa browse dulu apa sih topiknya. Anda bisa melihat yang berkaitan dengan geothermal system yang di Tangkuban Perahu. Ada yang belum pernah ke Tangkuban Perahu? Sudah semuanya? Oke ya. Saya harap Anda bisa browsing di Tangkuban Perahu itu ada apa? Kenapa diteliti sama Pak Syahreza? Ya. Kemudian yang berikutnya Pak Rinaldi. Ini yang kemarin kita mendapatkan musibah yang gak jadi kuliah lapangan kecil itu karena Pak almarhum Pak Arfi ya meninggal. Nah, ini Cilatuh ini lokasi yang seksi. Ya, banyak diteliti dari pihak luar, banyak dilakukan kunjungan. Silakan. Banyak dilakukan kunjungan oleh para peneliti asing, ya, termasuk yang mungkin nanti akan menjadi topik diskusi. Ya untuk Cilatuh. Yang depan untuk dosen katanya. Nanti disuruh pindah yang depan untuk dosen sini. Oleh fakultas dialokasikannya untuk dosen. Nanti bisa diusir masalahnya ya. Tadi aja yang di depan udah diusir tadi. Oke, jadi silakan di depan di sini. Ini masih kosong. Ini udah penuh di sini ayo. Ayo ke depan. Oke, jadi kalau Anda lihat topik ini, Anda mungkin sudah bisa browsing. Ya sudah bisa nanya ke Neng Ai atau ke ChatGPT atau ke Gemini, topik-topik yang berkaitan dengan judul ini. Ya. Jadi tadi yang pertama tentang Tangkuban Perahu oleh Pak Dr. Syahreza Angkasa. Kemudian yang kedua Pak Rinaldi itu akan berkaitan dengan Cilatuh topiknya. Ya. Anda bisa browse, kita masih punya waktu sedikit. Nah, kemudian yang berikutnya Profesor Yu itu berkaitan perubahan magmatisme di Sumatra dan Jawa. Nah, kalau di mekanika teknik nanti Anda akan belajar tentang vektor, tentang resultante gaya. Magma ini sebagai bagian ya dari kerak bumi yang muncul ke permukaan membawa energi. Nah, gaya itulah yang kita pelajari. Nah, isinya seperti apa Profesor Yu nanti saya juga tidak tahu. Kita lihat nanti bersama ya. Kemudian Profesor Jeremy Sung itu berkaitan dengan plate tectonic history atau sejarah tektonik lempeng. Saya belum tahu isinya tentang apa, tapi tahun 94 di Taiwan ada sebuah gempa besar namanya Chichi earthquake. Itu masih menjadi acuan sampai sekarang. Nah, kemarin beberapa kali rentetan gempa besar di kita dan di seluruh dunia, ya, dari mulai Amerika Latin, Jepang, Indonesia. Ya, di Indonesia juga berkali-kali, di Jepang juga berkali-kali. Ini kaitannya nanti dengan plate tectonic history. Saya karena bidang saya di kebencanaan, yang akan menjadi sorotan nanti tidak hanya berkaitan dengan kegeologian, tapi aspek hilir. Ya, bisa saja kebencanaannya, bisa saja aspek mineral, aspek. Oke, makanya diberi judul revisiting. Revisiting itu apa bahasa Indonesia-nya? Ya, kunjungan kembali gitu ya, atau mendaur apa barangkali daur ulang begitu kira-kira. Tektonik dan magmatisme di Jawa dan Sumatera. Ini sebagai informasi, barangkali Anda boleh cek nanti lewat AI. Satu kata kunci yang sedang ramai di kita yang disebut sebagai critical mineral. Ya, critical mineral itu yang dituju oleh banyak sekali negara-negara maju. Salah satunya adalah berkaitan dengan logam tanah jarang, REE, atau rare earth element, unsur tanah jarang. Nah, critical mineral ini kaitannya dengan industri. Minggu lalu, fakultas kedatangan tamu dari laboratorium kerjasama CSU Cina dengan ITB di sini. Dan mereka punya alat-alat lab yang canggih, terbaru seluruh dunia. Ada alatnya. Katanya sih saya dengar lab yang baru ini berharga kurang lebih 1 triliun, 1.000 miliar. Ya, terutama kepada metalurgi. Ya. Kalian tahu, siapa ada yang tahu Menteri Pendidikan Tinggi dari mana jurusannya? Ya? Ada yang tahu namanya? Kan kemarin ke sini ke Unpad. Menteri Pendidikan Tinggi. Siapa? Enggak tahu. Coba dibuka. Buka WA itu saja. Siapa Menteri Pendidikan Tinggi? Pak Brian. Pak Brian Yulianto, Prof. Brian Yulianto itu ahli metalurgi dari jurusan metal ITB. Ya, nah beliau ini menggagas pembentukan lab yang cukup besar. Jadi nanti silakan kalian browse tentang critical minerals dan itu mungkin menjadi salah satu tema bersama. Silakan Pak Dekan. Ini mengisi sambil menunggu. Assalamualaikum. Sehat. Please welcome. Hello. Nice to meet you, sir. I'm Diki. Yeah, thank you, sir. Yes, please. Nice to meet you. Assalamualaikum. Ayo, sehat. Silakan. Ayo di sini. Boleh. Jadi itu informasinya, silakan nanti Anda aktif ya menyimak presentasi yang kita dapatkan. Terima kasih, saya kembalikan ke panitia. Assalamualaikum warahmatullahi wabarakatuh.
Pagi Pak.
Sumatra.
Ada acara juga Pak. In English juga. Sudah siap? Ya, Babar nggak perlu diantarin Bu. Silakan aja langsung. Berarti apa dulu Pak? Oh itu ininya departemennya. Video.
tentang menggali sumber daya, tetapi juga tentang membaca setiap perubahan alam, mengurangi risiko bencana, dan menjaga keberlanjutan kehidupan bagi generasi mendatang. Disinilah ilmu geologi menjadi sangat penting.
Selamat datang di Fakultas Teknik Geologi Universitas Padjadjaran. Kami percaya
eksplorasi sumber daya geologi terdiri dari minat sekolah, biasanya melalui bidang teknologi, jenis, konsepsi geologi dan potensi hilirisasi wilayah lingkungan, sumber daya geologi pengembangan. Kelompok riset berbasis rekayasa sumber daya geologi terdiri dari kelompok riset pemrosesan sumber daya
To begin our formal session, may I invite all distinguished guests and participants to stand, if possible, for the singing of the Indonesian national anthem, Indonesia Raya, followed immediately by the Universitas Pajajaran hymn. Please remain standing throughout both anthem. Please stand up. Thank you. Please be seated. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Welcome to today's prominent event, the joint collaboration of DiGDaya 25th edition and FTG Studium Generale, hosted by the Faculty of Geological Engineering Universitas Pajajaran in partnership with the Research Center for Geological Resources, National Research and Innovation Agency BRIN. It is our pleasure and honor to warmly welcome our distinguished guests and institutional leaders. The Honorable Dr. Engineering Iwan Setiawan, Head of the Research Center for Geological Resources, National Research and Innovation Agency BRIN. The Honorable Dr. Engineering Boy Yosef Cahya Sunan Sakti Shah Alam, STMT, Dean of the Faculty of Geological Engineering, Universitas Pajajaran. The respected Dr. Science Yoga Andriana Senjaya, Vice Dean for Learning, Student Affairs and Research of the Faculty of Geological Engineering, Universitas Pajajaran, who will also be guiding our scientific discussion today as our moderator. Our speakers, Professor Jeremy Sung Jui Wu from National Taiwan University, Professor Yu Ming Lai from National Taiwan Normal University, Dr. Sahreza Saidina Angkasa, STMSC, researcher from the Research Center for Geological Resources BRIN, Dr. Science Rinaldi Irkram, STMT, lecturer and scholar from the Faculty of Geological Engineering, Universitas Pajajaran. And the last is wonderful welcome to all our participants, researchers, students, and geological enthusiasts connecting with us from various places. Thank you for your presence. On behalf of the organizing committee, I would like to extend our warmest welcome to all distinguished guests, speakers, moderators, lecturers, researchers, students, and participants joining us today. It is a great pleasure to have you with us for DiGDaya 25th edition and FTG Studium Generale under the theme Revisiting Tectonics and Magmatism of Java and Sumatra. We hope today's program will provide valuable insight, meaningful discussion, and opportunities to knowledge exchange in the field of geological sciences. Distinguished guests, ladies and gentlemen, to officially open today's event, we would like to invite our first institutional leader to deliver the welcoming remarks. Please welcome the Dean of Faculty of Geological Engineering, Universitas Pajajaran, Dr. Engineering Boy Yosef Cahya Sakti, STMT, to the stage. Pak Boy, the floor is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good morning and warm greeting to all of you, distinguished guests, Dr. Eng Iwan Setiawan, Head of the Research Center for Geological Resource BRIN. Our distinguished speakers, Professor Jeremy Sung Jui Wu from National Taiwan University, Professor Yu Ming Lai from National Taiwan Normal University, Dr. Rinaldi from Universitas Pajajaran, and Dr. Sahreza from BRIN. Yes. Our moderator, Dr. Yoga Andriana, and all distinguished college researchers, lecturers, students, and participants joining us on site and online. First of all, let us express our gratitude to God Almighty for allowing us to gather today in DiGDaya 25, Fakultas Teknik Geologi, Studium Generale, joint organized by Research Center for Geological Resource BRIN and Faculty of Geological Engineering Universitas Pajajaran. On behalf of the Faculty of Geological Engineering, I warmly welcome all speakers and all participants and sincerely appreciate your presence and contribution to this important scientific forum. Ladies and gentlemen, today's theme is revisiting tectonic and magmatism of Java and Sumatra. Is highly relevant to our understanding on the geological evolution in Indonesia. Java and Sumatra are located in one of the world's most active tectonic regions. Subduction, crustal deformation, and magmatism. This completely makes Indonesia an extraordinary natural laboratory for understanding Earth process. The term revisiting is particularly meaningful. Geological understanding is never truly final. New observation, data set, technology, and analysis approach can provide the new interpretation of process that we previously consider well understood. This perspective remind us to understanding in geological Indonesia require integrated, multidiscipline, and continuously evolving scientific approach. For our student, this event is also very important opportunity to learn that the geology is not merely a collection of facts. It is a dynamic science developed through the observation, research, discussion, and the question existing interpretation. Ladies and gentlemen, I would like to emphasize the strengthened collaboration between BRIN, Universitas Pajajaran, particularly in research, publication, knowledge exchange, capacity building, and the development of the young scientists. I sincerely hope today event will become part of the long-term and the productive scientific partner between our institution. Finally, I would like to express my appreciation to BRIN, all distinguished speakers, the moderator, and the organizing committee, and everyone who was contributed make this event is possible. May DiGDaya 25 Studium Generale provide the new scientific insight, inspire future research, and strengthen our collaboration in advancing earth science. Let us continue to explore the geology of Indonesia, not only to understand our geological past, but also to support a more sustainable future. With great pleasure, I officially declare DiGDaya 25 FTG Studium Generale with the theme Revisiting Tectonic and Magmatism of Java and Sumatra officially open. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much to Dr. Engineering Boyosef Cahya Sakti for your inspiring words and for officially welcoming us to this collaboration event. Ladies and gentlemen, moving forward to our next agenda, we would like to invite the head of the Research Center for Geological Resources, National Research and Innovation Agency BRIN, to deliver his opening remark. Please welcome Dr. Engineering Iwan Setiawan. To Pak Iwan, the podium is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So, first, I would like to thanks Pajajaran University, Pak Boy, as a Dean of the Faculty of Engineering Geology, Pak Yoga, and also Pak Diki Muslim, all the teachers, all the seniors. And also, I would like to express my deepest gratitude to Professor Yuming Lai from National Taiwan Normal University, from Professor Jeremy Wu from the National Taiwan University. So Yuming is normal, while Wu is abnormal. Yeah? And also to David. Yeah. I didn't prepare any slide for this talk, yeah. Already present before the video. So to us that our institute is belong to maritime and earth sciences. Yeah, we are one of the research centers among the Organization of Maritime and Research Science. We also have another research center as oceanology, deep sea, yeah. Limnology. We also have a disaster and climate and atmosphere. So belong to our research center, we have 8 research group. Yeah, you saw before from the video, we have exploration research group, pillar, and then we have engineering georesources pillar. The other is the conservation geological resources. So on the first pillar, we have exploration geology, we have a mineral energy research group, geochemistry, geochronology, and mineralogy research group, geothermal, marine geology, downstreaming of the associated mineral, and still many more. We also have many schemes for all the students here. You can join our schemes for scholarship, yeah, for the internship, and also for the foreign collaboration. Most of I invite all of the students here to join the BRIN internship program. Yeah. Maybe next 2 years or next years, you can join our scholarship or internship in BRIN. We will provide you the allowance for tuition fee and also for monthly fees. Yeah. There are many research groups. Again, I invite you, all the students, to join BRIN. Anyone who wants to be a researcher, anyone who will continue his study or the study, you can also join our research group. We are not only geological resources. In BRIN, we still have many more research centers. We have also many expertise. You can deeply more study in what you want to continue for the future career. Yeah. And I also thank to the organization committee, yeah, Pak Danang, Pak Aryo, Mbak Fia, yeah, and also colleagues from BRIN. This is not the end for our discussion or meeting. I hope anytime you can come to the institute in Bandung. I will be very happy to welcoming you all for the next collaboration. Again, I thank for this today collaboration webinar. I hope the webinar can have a fruitful discussion, meaningful for all of us, and can inspire to all of the students. Thank you very much, and have a good day and discussion. Thank you.
Thank you very much, Dr. Engineering Iwan Setiawan, for your valuable remarks and insight on this significant research collaboration. Ladies and gentlemen, to capture the memory of this remarkable collaboration, we will now proceed to the group photo session. May sorry, please remain. We will host the souvenir presentation to honor our esteemed partnership and our keynote speakers. We would like to invite the Dean of Faculty of Geological Engineering, Universitas Pajajaran, to present the tokens of appreciation to our keynote speakers. Profesor Jeremy Sung Juiwu, Profesor Yu Ming Lai, Dr. Sahreja Saidina Angkasa, and Dr. Science Rinaldi Irkam. Let us give a round of applause for this exceptional partnership. Thank you. Please remain on stage, Bapak. Yeah, ladies and gentlemen, to capture the memory of this remarkable collaboration, we will now proceed to the group photo session. May I respectfully request the Dean of FTG Unpad, the Head of Research Center, the Geological Resources BRIN, and all our distinguished keynote speakers to step forward to the center of the stage. For all participants joining us online via Zoom, please turn on your cameras, put on your best smile, and our committee will capture the screenshot across our virtual screens.
Okay, ladies and gentlemen, we will now have our documentation session. Please be so kind to turn on your camera. Everyone, please turn on your camera and use our virtual background. Start.
Mahasiswa mohon untuk berdiri, kita akan melakukan photo session. Silakan untuk berdiri. Hadirin yang di ruangan mohon untuk berdiri. Kita akan melakukan photo session. Ladies and gentlemen, before we continue our agenda, please allow me to make a brief announcement. We would like to express our utmost gratitude to Dean of Geological Engineering Universitas Pajajaran, Dr. Engineering Boy Yosef, for being with us today. He must kindly leave the venue at this moment. Once again, thank you very much to Dr. Boy. Ladies and gentlemen, we have now arrived at the main scientific session of today's event. To guide us through the presentation and discussion, we were honored to have Dr. Science Yoga Andriana Sanjaya, STMT, as our moderator. Our moderator today currently serves as the Vice Dean of Learning, Student Affairs and Research of the Faculty of Geological Engineering Universitas Pajajaran. He completed his early academic journey right here, earning his bachelor's degree in Geological Engineering from Universitas Pajajaran. He then pursued his advanced global education in Shimane University, Japan, where he successfully obtained both his master's degree and doctoral degree in geoscience. As a dedicated scholar, he has been deeply shaping the next generation of geologists as a prominent lecturer in the Department of Geological Engineering at Universitas Pajajaran since 1999. Ladies and gentlemen, please welcome Dr. Science Yoga Andriana Sanjaya. Dr. Yoga, the floor is yours. And may I kindly invite all speakers to join Mr. Sanjaya on the stage. Please join.
Okay. Good morning, everyone. Assalamualaikum warahmatullahi wabarakatuh. Thank you for all coming, Your Honorable, the Head of Research Center of Geological Resource, Dr. Engineering Iwan Setiawan, and unfortunately the Dean, Mr. Boy, has to leave this occasion, but he is very thankful, and most of all, the Faculty of Geological Engineering is so fortunate and so thankful of having Professor Jeremy and Professor Wu to be with us. And as we know, today there will be 4 speakers, Professor Jeremy, Professor Wu, and Mr. Shareza, and also Pak Rinaldi, who are also an alumni of our faculty. Well, let's just start. Can I please ask the speakers to come join me in the front? The first of all, Professor Wu, please join. Okay. Yeah. So this is the difference between Indonesian name and Chinese name, because we pronounce their family name. Professor Lai, thank you very much, and Wu. Okay, and Professor Wu. Both of them are from National Taiwan University, so we are so grateful and so honored and so fortunate having both of them here. So maybe the other speakers later, or please come, please join us. Mr. Shareza, he's also an alumni. He graduated from Faculty of Geological Engineering, and Mr. Rinaldi. So if you see here, excuse me, maybe I'm the oldest, as you can see. So he's the youngest. Well, I will just give you a brief introduction. Has his bachelor from National Taiwan University from 1998, right, Professor Lai? You graduated and 2000. Yeah. He entered in 1999 and 2000 and maybe 2002, 2012. Okay. So, so he took his bachelor, master's, and his doctorate at National Taiwan University, if I'm not mistaken. And Professor Wu, he also graduated from National Taiwan University, but he took his doctorate in University of Houston. Yeah. So he's part of and Mr. Shareza here, as you all know, he is a class of 2007, but he took his master in Oslo and he took his doctorate in Akita, right? And Mr. Rinaldi here, he's also from our university, so he's a class of 2011. He took his master's in University of Pajajaran and then also took his doctor at Akita University, just like Pak Iwan. So this is all his juniors. So please have a seat, young speakers. Maybe we'll just go straight to the first speaker, Professor Lai, please. Yeah. So, my dear students, Professor Lai will describe, give a lecture on magmatism. We all know Indonesia is a ring of fire, and it's so interesting to understand the magmatism and related tectonics related to our archipelago. So I think this will be a very important lecture from all of the speakers. Please, the floor is yours.
Okay, thank you everyone. Okay, good morning everyone. My name is Yu Ming Lai from National Taiwan Normal University. My department is the Earth Science. So it's my pleasure to be invited to the Pajajaran University today. And my topic will be Java and the Sumatra, chasing magma through time, and collaboration with BRIN. And this photo is my first time to visit Sumatra. And our target is the Sinabung volcano. But when we were very close to it, eruption in front of us. So that is my first time to meet an active volcano eruption. So it's interested me and very happy. So next. So today my outline, I will give 5 W and 1 H to everyone. Next. The first one is why Indonesia. Next. So Indonesia is there. I think everyone is much more know that than me. I came from Taiwan. Taiwan is here. So that is, the distance is not so far, but still not so close. So before I came to Indonesia, the image for this country to me is a lot of volcano. And then because it's laid on the tropical line, so the weather will be very hot. And a lot of beautiful islands, and also very warm people. And especially foods, delicious foods also. So today I want to talk about why Indonesia become a very distant, far away country from Taiwan into a very important part of my scientific journey. Okay, this is Sonda land. So you can see around the Sonda block, they have a lot of subduction system. And here is Taiwan. When I was a PhD student, I studied the volcano in the eastern part of Taiwan and the northern Luzon. So that means the northern, the Luzon arc. So I studied the magmatism and the volcanism. And this is Sonda arc. It included Sumatra and Java. So I just want to use the experiments what I study in the Luzon arc to into the Sonda arc. Okay, next is what are we looking for? Simply speaking, is subduction zone. So you can see, as you everybody know, the subduction system, the subduction slab dehydration and let the mantle wedge partial melting to form the magma. So the magma arise, stay or directly through the crust to form the volcano. So studying the igneous rocks in the, from the volcano, we can understand the magmatism and the volcanism just in the subduction zone. And also, the subduction slab is not always stable. Sometimes that will be tearing, rollback, or break off. So if this tectonic system happen, that will be let the magmatism and the volcano change through the time and the space. Next is how do we study it? First thing is I want to know the age of the igneous rocks. So the methods we use zircon, uranium, lead dating. And here is the isotopic system, a decay system. And why zircon? Because zircon is so solid and it's very hard to weathering. And you can find zircon in each type of rocks. Igneous rocks, sedimentary rocks, even metamorphic rocks. And we can use the CO image to check the structure of the zircons and identify which part we want to know the age. So the age plus the structure will be the history. And we also collect the samples from igneous rocks to do the whole rock geochemistry. Included like major trace element and isotopes. So the samples were from the outcrop or along the beach and the boulders in the river and in the farm. So the target samples will be igneous rocks plus like river, beach sands. And we will analyze the petrography and the whole rock major trace element isotopes and the uranium lead dating and the layer hafnium isotopes also. So where have we been? So since from 2013, we visited Sumatra, and through to 2016, I stay in Sumatra, and then moved to Java and meet Iwan and BRIN. At that time, it's Lippy. So actually, we just back from the East Java yesterday with the BRIN team for the field trip. And then will be what we have learned in the past 10 years. I will use these 4 publication, already public paper to introduce what some part of what we already have. First one is focused on the western part of Sumatra. So we found in the southern part of the Sumatra fault here, that is much older volcanism. And in the northern part of the Sumatra fault is much younger. So not only our zircon ages, but also you can see the potassium argon ages from the previous study. On that photo, you can see the blue one is volcanic rocks from the southern part of the Sumatra fault, and the yellow one is the north. So it significantly can see the magma from magmatism is changed from the southern part to the north during like 15 to 5 MA. We also do the chemistry, so you can see from the southern part to the north, the K2O content is getting higher. So we try to combine the model in Java. Is that like the change side geochemistry with the lower K2O and the backup side have higher. And then for the isotopes, also from the southern part to the north, the epsilon neodymium is getting enriched, but not so various. And this part of the magmatism is very different than TOBA. So it means the TOBA magmatism is totally not related to the western part of Sumatra. So we have 2 conclusions. First one is why the southern part of Sumatra, western Sumatra, the volcanism is stopped. We believe that because when the Indian plate collect to the Asian plate, the subduction ceased from the northern part from Burma to the south, changed to the strike-slip motion, and moved to the western part of Sumatra. That will be let the subduction change to the strike-slip motion. So the southern part of the volcanism just stopped. And for the northern part, it's also affected by this motion, but start from the Sagaing fault move and let the Andaman Sea opening. So when the Andaman Sea opening, the lower part of the asthenosphere will be arise. So the extra heat just let this subduction system rework again. And the second paper is talk about the whole Sumatra island. We try to combine the privacy dating works from the potassium argon, and the rubidium strontium ages. So you can see the number is the privacy study, and the foam is from the zircon uranium lead dating from our work. We separated all Sumatra into 4 parts: the western part, Toba part, central part, and the eastern part. So combine our study with the privacy study, we can see all the Sumatra area have a magmatic gap from like 48 MA to 23 MA. And you can see when we deeply see each part, you can see the first one, the Western Sumatra, the gap is there. And here, when it younger, like, still have a gap. We already talked about that. In Toba area, they only have the younger part. And for that one is inherited zircon. And for Central Sumatra, there is a typical Sonda arc significant signal. And this part is the magma gap. Also in Eastern Sumatra have the magma gap and also two small gaps. But so far we still try to find why they have a gap. And including the inherited zircon, we can have the story since from the Paleo, Meso, Neo-30s to Indian Asia collision and the magma gap in Sumatra. And then start from the Indian Australian subduction, the volcanism start again. Okay, the third work is given by lady who is just sitting there. She focused on the Pachitan area in Java. We find 3 stages in Pachitan. The oldest one is from 28 to 26, including the inherited zircon will be 30, from 30 MA. And the second stage will be about 20 MA. And the youngest will be start from 13 to 11. All of the geochemistry is from basalt to rhyolite and the low K to medium K. And we use the stage 2, the red one, for standard. You can see the first stage RE concentration is lower, a little bit lower than the second stage. And compared to the last stage, we can identify to 2 groups. And the green one have the much more lower heavy RE. And this green one, we find it is adacatic rocks. And each steps we also find they have the fractionation of the crystallization. And for the epsilon-neodymium isotopes, all of samples from Pachitan is much more depleted than the other samples from Java. So in the end, we just give 3 stage models. The first stage since from 13, or actually is 28, the old andesite eruption. And then the ridge subduction let the subduction just stop. And the subduction angle change, roll back and break up, so let the asthenospheric upwelling to melt the slab to form the adacatic magma. And then the convective mantle flow also come here. Let the normal partial melting of the mantle ridge. So the normal ADR magma also form at that time. So this work, we just have one conclusion. It is the old andesite is not so old, and the ridge subduction is not so young. Okay, so the final one. We go to the east part of the West Java, and they have 2 volcanoes, Sonda, Takuban Perahu belong to the Rio Arc part, and Gade and Malaba belong to the volcanic front. And we also have the Gantur. Gantur is a boundary between these 2 parts. So according to the concentration of the K2O, you can see the Rio Arc one have higher K2O compared to the volcanic front one. and we also get some new edges. For the trace element, we use DiGDaya, the gray one for the standard. You can see the real arc volcano have higher RE patterns compared to DiGDaya. And the Malabar volcano is the same with DiGDaya. But very interesting is contour. You can see the contour volcano have two types of the both of them. So we just suggest the contour is the boundary between the real arc and the volcanic form. So also based on the epsilon Newtonian isotope, we can say the volcanism from the trenchside will be getting higher degree of partial melting and then lower crustal continuation, like Malabar and DiGDaya. And the backup side, that will be few degree of partial melting and the higher contamination, like Sonda and the Takuban Parahu. Okay, that's 4 works, and also we have some works in the West Java. Here we have there are 2 students, master students from my lab. They also have some regional slab tectonic variation. So last one is what's next we go from here. So from the prevalence study, they talk about the slab geometry from Sumatra to Java have a large scale, like a slab tearing, a slab rollback or something. But we just thinking about if this kind of the slab geometry change will not only cause in the large scale but also in small scales. And some of people in our group, they also from Taiwan, they also finished some samples from Sulawesi and the other Banda Arc Islands. So if we combine all of the data, maybe we can try to understand the subduction timing and geochemistry variation from the whole Sonda Banda arc. Okay, so since 2017, we collaboration with LIPI. And then 2018, also 2019, next. And then the COVID is coming. So after the COVID, 2023, we come back again. And again. And this is this year. So this is the Toba Lake. I very enjoy the field trip and I very love Indonesia. This is the second country I most visit in the whole world. That is my presentation today. Thank you.
Thank you very much, Professor Lai. You may sit. Okay. Next, because there's 4 presenters, 4 persons who's going to speak, so all of them are going to speak their lecture, and then maybe after that, after 4 of them have give their lecture, they will have a question Q&A session. Now, let Professor Wu to start his yes. With others, you may sit here if you want to see, so later we can sit in front on the discussion, please. So it's gonna be hard on your neck if you
Okay. Whoa, the font is different, but anyway. Okay, thank you for inviting me to here for lecture my works in the past 10-ish year. And actually, this is my first time being in Indonesia, and I really like everything that I've been here, like the food-wise, and also the people, and also the views are all new and all interested to me. and I really appreciate it for the chance that I can visit here. And before I step into my work, I want to apologize for not be able to deliver anything that is directly related to Java and Sumatra, which is the main topic of this talk. I mean this event. And my excuse is that I spent the past 10-ish year in another part of the world, which is the Northeast Asia, including Japan and like Russian Far East, which is the main field trip that I have gone to, the Russian Far East, and also Korea, like that area. Well, sorry, I just want to step in here. Like I'm talking about here, while like we're around here in West Java. The main working area I've been is here in the Northeast Asia and also the Northwest Pacific. So having said that, I had applied this strategy for plate reconstruction for the study area here, and I believe that the same strategy can actually apply to Java and Sumatra as well. And therefore, the main topic I want to sharing today is actually the strategy I have using on doing the reconstructed plate tectonic history of the Northeast Asia and Northwest Pacific. So this is my outline. I'll first talk about the kind of define what do I mean by plate tectonic reconstruction, like what I'm exactly reconstructing for. And the second one, I'll jump to say like what do we have, like what's the object that we can have to reconstruct the plate for oceanic plates. And the third topic would be like I will use Northwest Pacific as an example for plate reconstruction, then jump to talk about a little bit about what can we do after we have this plate reconstruction model that have been done. So yeah, first I want to talk about the term of plate reconstruction. So when hearing this term, some of the students, at least in Taiwan, they will kind of having this view in their mind, like it's reconstructing for a supercontinent back in time, which is Pangaea, okay? And so people have applied all kinds of geology to reconstruct, like put the pieces of the continents back in time to where their place belong to. And so I would say this is also an important part of plate reconstruction, but this is just half of the story, okay? Like you can see the map on the right side, which have reconstructing the complete Pangaea around 200 million years ago, all the way to present day. So they are mainly working on where the paleolocation of these continents were. But I would say that's only half of the story. The other half is actually in the ocean between these continents. Like in those oceans, there were also oceanic plates that have been occupied those area. And I will say, in sometimes reconstructing oceanic plates is actually much more important than reconstructing the continental plate. And the reason why I'm saying that is because, well, if you look at today's, especially for like convergence margin, like the Ring of Fire, I'm talking about like Japan, like East Asia, and also Java and Sumatra as well. Like when earthquake or volcano happens along this Ring of Fire, we will think of the subducting oceanic plate. So if you go back into geology time, say like let's jump back to 100 million years ago, when we talk about a arc magmatism somewhere here in the Andes, we will think about what was the oceanic plate that was subducting along this margin to cause that arc, like the volcanism. So in this sense, actually we also need reconstructing the oceanic plates to understand the full story. Okay. Oops. Okay. And I would say like recent day, or say the past 10 years, have a significant advance on the plate reconstruction working groups. So one thing is that this app called I would say this software called G-Plates have been being invented. Like this software is developed and also maintained by a group in Australia called the Earthbite Groups, and it's a open access software, which means that anyone can download it, and then you can use this software to access those existing plate reconstruction model like this one. And also, if you don't like the reconstruction model that already exists, you can also use G-plates to make your own reconstruction model, like digitalize it as well. So, like the Earthbyte groups have been publishing some of the reconstruction model they have from time to time, and this is one of them. But you don't have to believe them. So this is a view for the general Pacific region. As you can see, the blue arrows are showing how the Pacific plate was moving through time. And like this is their story, which I actually not like buying it in most part of the Pacific. So I and my previous supervisor and also my colleagues in the National Taiwan University were working on to revise this story as well. So, but having said that, like there's an obvious question is that, okay, we want to reconstruct the oceanic plates, but so oceanic plates is we're actually trying to reconstruct that something is already gone into the Earth's surface, like it's no longer exists on the Earth's surface anymore. And especially when you compare to continental crust, which can be preserved for a long time, like the oldest continental crust is around 3.8 billion years. And instead, for oceanic plates, the oldest one is just around like 180 million years. It's significantly younger than the continental crust. So it means that the preservation for the oceanic crust is much like worse than the continental crust. And it has reason for it, because we have this oceanic crust that is generally more denser than the continental crust. So it's like being subducted beneath all those trenches from time to time. But like, so how do we reconstruct something that is already vanished from the, the Earth's surface? That's the question that I mainly want to working on. So the strategy we have is actually like this. Like we have mainly like three things here that we can do something for it. One is the present-day oceanic plates. And the second one is subducted oceanic plates in the seismic tomography, and also those subduction-related geology along the convergence boundary. Don't worry if you couldn't read through all of this. I will go back to this slide later. So for the first one, the present-day oceanic plates, which had preserved this magnetic anomaly, which is from the, say we have, if you're familiar with the Earth's magnetic pole reversal from time to time, this reversal history also being recording in the like the oceanic crust when it generated from the mid-ocean ridge. And so from this magnetic belt, we can also constrain what's the age and also how wide is it on the oceanic crust. The next one. And so from that information, we can actually kind of say reword the clock backward, so we can understand how the present day existing oceanic crust was what's its parallel locations back in time. Could you play the movie? Like there's a so this is 0MA. It's what we're looking at this right now. Pacific Ocean has the oldest part here, which is the darkest part. It's around 160 million years ago. And then to the east, there's this East Pacific Rise, which is the mid-ocean ridge that generate these Pacific oceanic plates. So what I'm doing here is actually like kind of redo, I would say undo the oceanic plate generation for Pacific. So we can see the present day existing Pacific plate is become like smaller and smaller. So left this gray region, which of course there was oceanic crust that occupied area, and this is the unconstrained area that we want to working on. Like this is the place that we will come to do plate reconstruction. Okay, so next plate. The next slide. Yes. So, and of course, I'm not the first one doing this. Like, people have been proposing different models for this part of the world, and I can kind of like classify them into three groups. Like the model one is having this mid-ocean ridge between Izanagi and Pacific plate, it was kind of perpendicular along the Northeast Asian margin, and it was moving from south to north. Like this dashed line here is the location it was, like the mid-ocean ridge was here. Like in this model, the mid-ocean ridge was here around 130 million years ago. But like in this time, like 19 million years ago, it was here, like offshore the Japan islands. And the second type of model is that the same mid-ocean ridge was there, but it was more like parallel to the Northeast Asian margin. And the third one is that there's no mid-ocean ridge. Instead, there's a marginal sea there between the Izanagi and Pacific. So the main work that had been done for the past 10 years was like verify which model was true, or say was more close to the geology or the evidence that we're seeing on the Northeast Asia and also the mantle below. Okay, next one. So let's jump to the second strategy, which is like using the seismic tomography to look into the mantle structure and finding those plate that is already subducted beneath the continental crust. So this is a profile for the Northeast Asian margin, like from A to A prom. It's across the Russian Far East all the way to Northwest Pacific, and this is like Russian Far East, and this is Japan. So if you look at this profile, it's a seismic tomography image for this profile all the way from the surface down into the core mantle boundary. And for those who don't know about the seismic tomography, it's kind of a model that built with integrating this seismic array and also a velocity profile along the across the mantle and also the crust to identify those faster seismic anomaly or slower seismic anomaly in the mantle. And for these plates that already subducted beneath, like into the mantle, they are usually the faster seismic anomaly. I'm talking about those purple and whitish blobs here in this section. And also the red circles there is the Benioff zone earthquakes, which is kind of saying like it is the subducting Pacific plate. And now, if you look into deeper of this profile, there's another huge blob here, which kind of having a gap right there. And some of us believe that it is the Izanagi slab that is already down there, and that could be the mid-ocean ridge between the Pacific and Izanagi plate. So that kind of tells us that there must be a mid-ocean ridge having subducted along the margin. So we kind of rule out the model 3, if you remember like the 3 models. We kind of rule out model 3 according to this result. Next one, please. And we also done further stuff for playing with the seismic tomography, is that we did a strategy called the slab unfolding. It's kind of like we restore the original length of the downgoing, downgoing subducted Pacific plate by having several profiles across the margin, and then we had mapping all the volume, or say the area of this slab in each profile, and then reconstruct it back to where it's the length of its original, when it's still on the Earth's surface. So next, please. So with that, we had done stuff like a couple of profiles along the East Asian margin, and then we realized that it's, when we put everything together, it's kind of a reconstructed Pacific plate. And this boundary is pretty much where the mid-ocean ridge was. And then we realized that if this model is correct, somehow we will have to have something happen around 50 or 55 or 50 million years ago, because that's the starting point of the Pacific plate subduction. And also, if you believe that there is a mid-ocean ridge between the Pacific and the Izanagi plate that is already down there, then this could be the the time of mid-ocean ridge subduction along this margin. And also kind of showing that this mid-ocean ridge is kind of parallel to the margin. But I mean, have said that seismic tomography can have all kinds of uncertainties. So the third strategy we have is, of course, go back to on-land geology to look at what we have on the land to fit with this story. So for subduction-related geology, I believe all of you are quite familiar with it. Like subduction can result into earthquakes and also magmatism, and also it will have this accretionary present along the convergence margin, which is also having this records of the oceanic plates accretion through the subduction history. But here I will only focus on the magmatic part for the time's sake. But you're welcome to ask me about other parts. For example, like the oceanic crust accretion history can be quite helpful as well, but I won't touch that in this talk. Next, please. So for the magmatism, it actually can have some records for us to say identify what happens to the downgoing slab back in time. And this is a paper published by my friend Gato Gianni. Like he is trying to explain, saying that the location of the arc magmatism can vary when something happens to the downgoing plates. For example, if you have a slab advance, or say flat slab, then the arc magmatism will move inland. And for the opposite, if it's a rollback, then the magmatism will move outward to the like toward the trench. And also, if this is a case when the mid-ocean ridge was subducted, it could be creating this slab window in the mantle. And for this case, the slab window can cause the shutdown of arc magmatism and also some other anomaly magmatism at that time. So therefore, the strategy we have is that we have to build up a magmatic arc records for the Northeast Asia to identify all these things, and not just the location, but also the geochemistry as well. And for this approach, what like Dr. Lai had been described is extremely important, because we need all this kind of real-world data to constrain the magmatic records. I'm talking about the geochronology, like zircon dating, and also major trace, and also isotopic composition analysis for these igneous rocks, and which is also what I've been done for the Northeast Asia for the past 10 years. Okay, next please. So, like we have go to the field trip for this part of the world, which is the southern part of Russian Far East, and pretty much all the dots you're seeing here are my work, and also my supervisor, my supervisor back in master degrees works. So we also compile other data along the margin, including from Korea, Japan, and also Sakhalin there as well. And we come up this magmatic record for the area, saying all the way from 100 to 10 million years to 20 million years-ish. What we found is that there's actually a magmatic gap all along the margin. It's a wide margin, actually. It's like 2,000 kilometers wide. And that magmatic hiatus happens around 50 million years ago, which is the time of the mid-ocean ridge subduction that we had got from the slab unfolding from the seismic tomography work. So it seems like there's a fit. And also, if you look at the geochemistry before and after that hiatus, it's also different. Like this is the absolute endymion, and this is strontium. Like they are all getting into a more, say, like depleted, say, a more mantle-like signature after the hiatus. So we believe that there must be some kind of geodynamic reconstruction or say like reorganization events happening right there. And we believe it was the mid-ocean ridge subduction. And according to this database, it is kind of happens all along the margin, which also suggesting that this mid-ocean ridge was or say is parallel to the margin, and it's gone like subducting all along the margin at this kind of same time. Okay, next please. Yeah, and also we combine other geology along margin as well, which I won't dig into it. And just to, like for in the end, we kind of believe that the model 2, which is have a mid-ocean ridge between Izanagi and Pacific that is like parallel to the margin, and it was subducting along the margin around 15 million years ago. Like it is the story that we believe in. And therefore we come to this like reconstructing movie. Could you play movie? Yeah, thank you. So the blue one is the reconstructed Pacific plate, while the green one is the reconstructed Izanagi plate. As you can see, the mid-ocean ridge between here have been subducted along the 50 million years ago along this margin, and then after that is the Pacific subduction until the present day. And the color-coded part is the age of the Pacific plates that is still existing on the seafloor today. Okay, let's just wait for the movie again. Yeah, so it kind of saying like before 50 it was Izanagi subduction, and after that it was the Pacific subduction until present day for the Northeast Asian margin. Next slide, please. So kind of a little bit more things about what can we do when we have this reconstruction model. One thing we can do is that we can actually extract some of the geodynamic parameters from this model, including the first one is convergence velocity between the subducting oceanic plate and the Northeast Asian margin, which like before 50 it was the Izanagi, and after that this is the Pacific, and Pacific is extremely slower than Izanagi in this model. And also we have the convergence azimuth, which is like what's the direction of this conversion, and from that we can calculate the orthogonal convergence velocity through time. It can be transferred to slab flux along the margin later, of course. And also we have the subducting plate ages from that model as well. As you can see, the subducting plate was around 80 million years old at around like 100 million years before. And then this is the mid-ocean ridge subduction around 50. And then after that, the Pacific plate was subducting along the margin, and it's getting older and older. Until now, the offshore Japan has the oldest like oceanic crust at the present day world, which is like 130, or it's actually older, million years old. Like, okay. All right, and the other thing we can do is like when we have this kind of like the geodynamic parameter that have been extracted from model, and this one is the trench normal convergence from 100 million years ago to present day. We can look at this record and also compare with, or say go back to the magmatic record to see how the slab was doing to the magmatic arc through time. And in this case, there's one significant, say, or first order thing that I want to mention is that Izanagi is super fast. It's like 12 to 25 centimeters per year, and Pacific is slower. It's like 2 to 10 centimeters per year. And from this slow and fast subduction, somehow the Northeast Asian magmatism looks different. Like in the ultra-fast subduction, the magmatism was more felsic, like generally more felsic, if you look at the silica content of this rock. And also the isotopic composition also is more enriched, or say more like have an old signal, which showing by the absolute neodymium with the slower, like lower value. So this is also ongoing project that is actually already under revision. It can be out soon. Like we kind of talk about how plate, like we'll say subducting plate can control how the arc magmatism was doing through all this time. Okay. So go back to this strategy kind of roadmap. Like we have applied this strategy to the Northeast Asian margin, and actually I believe that the Northeast Asia actually have quite the similarity with Java and also Sumatra along this margin, because first of all we are all along the Ring of Fire, and so we have all this like long subduction history. And then Yumi had done, and also her colleague had done a lot of the work to constrain the magmatic history for this arc as well. So I believe that for this strategy, it can be applied to this region, and it can allow us to understand the whole history for reconstructing plate tectonic history and more and more. And I believe this is my last slide. And this is all I have today. Thank you for your listening.
Thank you very much, Professor Wu. As we can see, what he tried to explain is not in our region, but most of the part in Asia and most of Japan and in northern part of Taiwan. Okay, sebelum kita, before we continue, the organizer will bring up the barcode, so I hope everyone can take this barcode for presents. Please, I give you some time just to make sure that you're here. Silakan di foto aja barcode-nya untuk kehadiran ya, untuk daftar hadir dan mendapat e-sertifikat. Silakan. Pak Rinaldi ngambil juga. Udah diambil? Have you taken a picture? Okay, everyone? Okay, I think everyone already took the picture. Next, we will continue to our third speaker, Mr. Dr. Rinaldi Ikram. Please, the floor is yours. He will describe about maybe tectonics and magmatism in the West Java, mostly in Cilatu area. Silakan, Pak Rinaldi.
All right, thank you, Pak Wadek, atas bukanya ya. So I will deliver in English, and first thank you for the committee. Thank you for BRIN for making this event. This is very valuable for us, so we can discuss with all of students here. And thank you also for Mr. Iwan from BRIN and all the distinguished guest speaker. So today I will share our progress. So for a disclaimer, first, this is not most of the presentation is not yet published. So this is just a progress report from our team from Pajajaran University. So we have been working in this area. Maybe some of you already know Cilatu area in Sukabumi Regency. And here there's something that still mystery for us. So there's still unanswered questions. There's many things that we have to observe. And yeah, this is magmatic and tectonic dynamics of Cilatu complex, West Java. So I will talk, previous speakers talk about more broader area, like regional area. But I have small size area that have variation, have heterogeneity of magmatic and tectonic history. And okay, next. Okay, for the methods, this is like conventional methods. Conventional methods. So, I will discuss the introduction, where the location of the Cilatu and geological and stratigraphic setting, data and methods, then field and petrological diversity, mineral chemistry and geochemistry, and last we have discussion and paleotectonic reconstruction. That's still in progress. Right? Okay, next. So for those of you that who that doesn't familiar with Cilatu, so Cilatu is located here, right? So I know that Dr. Lai has already explored all Sumatra and Java, but I think Cilatu was one of the area that overlooked. Yeah. So most of researchers keep this area, maybe because the small occurrence of geological phenomenon. But here in Ciletu we have this is the well known as the place in Indonesia where the melangs and ophiolites are exposed. Yeah. So many researchers already report this area, and with this complex geological feature, Ciletu plays a key role in reconstructing paleotectonic events in the Sundaland region, especially from Cretaceous to the Eocene age. So this Sundaland is already mentioned by the previous speakers. So there, the gray area is where is Sundaland, and here we have small area that maybe can make more dynamic history of this particular region. So Ciletu subduction regionally has been linked to the other melangs and ophiolites such as Lok Ulo in Central Java, and then along to the Cretaceous suture here to the Maratus, to the South Borneo. So for location, we can see here a small area of there. The next. So yeah, for location, so it is a UNESCO Global Geopark. Yeah. So everyone knows here is the beautiful place. We have so many waterfalls, beautiful beaches, and we have here the sea caves, and here we can explore and do anything. Yeah? And I will talk about this small area here. This is called Sodong Parat Peninsula. Yeah, Sodong Parat Peninsula. So this small area, maybe from the west to the east, only 500 to 700 meters long. But we'll see what's there. Yeah. Okay. So the first, the objectives of this research is to discuss about ophiolite-associated plutonic suites, to record the mantle melting, magma mixing, fractional crystallization, etc., magmatic processes. So this area is known as dismember ophiolites. Exposing serpentinite peridotite, heterogeneous plutonic rocks. We have greenschist amphibolites metamorphic, and Eocene forearc sediments. So within these melangs, there is small peninsula that I already showed you before, that expose a laterally continuous but structurally disrupt plutonic body, yet preserve many kinds of lithology. This small volume occurrence, therefore, a natural laboratory for multi-characteristic petrology and geochemistry and sensitive reorder of magmatic and tectonic dynamics. So the objective is to characterize the field distribution and petrological heterogeneity of Sodong Parat, and their association with mantle peridotites. Constrained mineral chemistry and whole rock geochemistry, and to access multi-characteristic petrogenesis in subduction-related environment, and to reconstruct the magmatic and tectonic evolution in Ciletu forearc system for regional paleotectonic models. Next. Okay. For regional frameworks, as you can see on the map, so this is the variation of lithology that we already observe, and it's already mapped. So here the location is part of southern mountains of Java. Yeah, the one that the old andesit formation distributed, and it's comprised serpentinite peridotite, gabbroic rocks, metamorphics such as greenschist and amphibolites, forearc sediments, brachia, etc. Many types of lithology. And for the age, we know that this is young subduction. It is younger than previous expected. Previous researcher said that Ciletuh is we have similar age with Lok Ulau and Meratus, which is Cretaceous in age. However, the many absolute dating has already report that the age of Ciletuh is younger, which is Eocene, not Cretaceous. And here, what is the make this area what to say? It's complicated. What makes this area more complicated than other area? Because here, all of lithology is already deformed, disturbed by tectonic activity. So we have here foliated ultramafic, foliated gabbro, and all has already undergone metamorphism within low grade to medium grade level. And here we focus on this area. So here, a small area, and the red color is peridotites, serpentinites, ultramafic. So here, the pink area here, a very small distribution. We have the gabbroic rocks. Next. Okay, for the stratigraphic and age framework, so here so we have the range of age for each units, and for gabbro, here we have gabbro units. The potassium argon study potassium analysis has already yielded the age of 56 million years, but recently we have updated uranium lead zircon that mentioned the age of 67 to 70 million years age. Okay, next. Yeah, it's okay. Next. Yeah. So yeah, Ciletuh ophiolites is an incomplete dismember Penrose sequence. So from bottom we have here the mantle sequence, so the mantle part, and here we have the crust top part. But however, no sheeted dike complex found. So yeah, it's dismember, incomplete, or perhaps for like dikes or diorites that should be in this sequence was already metamorphosed into like amphibolites. So what we found is here incomplete dismembered. Okay, this is our publication back to 2025. So this is the variation of mantle. So we have type 1, which is the magmatic cumulate with low phosphatate number, and we have type 2 and type 3 of peridotites. So it's part of a 4-arc mantle. So we can see by the this plot for magnesium number to versus chromium number, and here also. So the variation we have here. So the plots fall into the suprasubduction, and yeah, belongs to suprasubduction zone. But for type 1, so we have the type 1s fall out of the mantle. So we consider the type 1 as the magmatic cumulate. Yeah, next. Okay, this is the variation of lithology at Sodong Parat Peninsula. So we have here 500 to 700 meters, but here we have various type of igneous rocks. So here is the occurrence, field occurrence. So as we can see here, we have irregular contact for each lithology. Due to the high deformations, so it's hard to distinguish and it's hard to define what is the origin structure of all of this lithology, and the associations also still in debate. So, for example, we have here the irregular contact and for the gabbro, coarse gabbro, and iron titanium gabbro. Here same. So we have here also like I don't know what to say, maybe enclave or xenolith. So we still consider what's the relationship for each lithology here. So here we have monzodiorite, and here we have the quartz monzonite. Next. Yeah, so here the characteristics. We have discontinuous irregular contact, enclave, packoids, blocks in matrix fabric, reflects intense tectonic disruptions. But we have continued evolution of mafic to felsic, such as gabbro, gabbroic diorite, monzodiorite to quartz monzonite. And here we have iron titanium gabbro occurs as discrete layers, enclaves and blocks. Next. Yeah, in the middle part, we found this micro gabbro here, but with different geochemical signature, which show boninitic signature from geochemistry characteristic. Yeah, next. Yeah, this is the petrographic analysis. So here we have from gabbroic characteristic, monzodiorites, iron titanium gabbro with rich of magnetites, ilmenites, and we have here, yeah, this one is the, we have this iron rich gabbro. However, so the most of the condition is of disturbed or already metamorphosed in green cyst to amphibolite facies. So we here it is common to find chloride, epidote, actinolite, sericides replacement to the origin of the lithology. Next. For mineral chemistry, so we have here the range of plagioclase and different type of pyroxenes, and for the microdiorites with boninites. So here we have also the CPX geochemistry that show the boninite characteristic. Yeah, for whole rock geochemistry, yeah, that lithology, the distribution can be shown here. So we have from the gabbro to the quartz monzonite, and here the iron titanium gabbros are at least evolved, and we have quartz monzonite is the most evolved with higher silica content. And yeah, from the diagrams, So we can see the range of the heterogeneous or large variation of plutonic rocks that we have here in small area. Okay, also note that the bimodal major elements behavior. So we have tholeic versus bonite affinity calc alkaline within one small pluton. So this is the evidence of multiple coexisting magma rather than a single differentiating chamber. Next. Okay. Yeah, for the spider diagrams. So yeah, so confusing actually. Yeah? So many variation here. So we have the evolved characteristic and depleted mantle. Yeah. However, we found the niobium tantalum anomalies across all not all, but some lithologies confirm a subduction modified mantle. So yeah, we can confirm that the subduction related petrogenesis is what occur in this particular area. Yeah, next. Yeah, for tectonic discrimination diagrams, as we can see, the characteristic of island arc tholeids and calc alkalines, and some, yeah, based on these diagrams, we can see the previous speakers said that it is important to what to say, to know the dates or exact chronological data for each lithology, but here is opposite. So we have variation of petrology and geochemistry variation characteristic. However, we cannot reconstruct. Yeah, it's hard to reconstruct because we don't know exactly the original structure and the chronologic of each lithology. Yeah, next. Yeah, so what we have here, this is our suggestion. So we have multiple magmatic lineage from tholeitic gabbro to quartz monzonite suite. And we have also boninitic gabbro and the iron titanium enriched gabbro. And co-occurrence in same occur in same small area on small plutonic complex. Next. Yeah, for this, yeah, this is just interpretation. Yeah, so far is interpretation because there is no absolute dating that we have already conducted, but looking the characteristic of geochemistry, we know there was a subduction related plutonic rocks with 4-arc spreading, and the development of a metamorphic soil. Then the middle Eocene we have abduction and 4-arc sedimentation. Then we have post abduction deformations in this area. Next. Okay, conclusion is the mystery continues. The coexistence of tholeitic, boninitic, and iron titanium enriched melts within a single 700 meters body raise more questions than its answer about how and where these magmas interacted at depth, whether the tree lineage share one parental males or are genuinely independent mantles, inputs later stitched together by faulting is still unresolved. The absolute timing of each magmatic pulse relative to mantle exhumation, metamorphic soil formation, and abduction remains unconstrained. Our four-stage model rests on relative, not absolute age. The petrogenetic link between the Sorong-Parat plutonic suite and the wider Ciletuh periodotite metamorphic soil system still needs direct isotopic and geochronological testing. And this study is only a snapshot, not a final word. So Ciletuh magmatic and tectonic history remains an active evolving questions, and the mystery is far from solved in the future. Okay, as I mentioned, so the future work will be the stable isotope chemistry and the absolute dating with multi-method geochronological approach. Yeah. Okay, thank you very much for your attention. And for here, Dr. Lai, if you have in the future, we have opportunity to collaborate with each other. So this is very interesting area to be studied. So I hope someday we can visit this area together with the Pajajaran University team. Okay, thank you so much for your attention.
Thank you very much, Kang Rinaldi. So as we can hear that, first of all, Professor Lai was discussing about Sumatra and Java, and then Professor Wu was talking about a more bigger area in the Northeast Asia and Northwest. And simply we come to our last speaker, that he's going to discuss the more nearest to our place, that is in the north part of Bandung, about Gunung Tangkuban Perahu. So please, audience, either who's in this room and also online, please prepare if you have any questions. So after this, we're going to have a Q&A session. Thank you very much. So, Mr. Sareza, the time is yours.
Udah apa ya? Cek. Okay. Well, thank you very much. It's good to be back here in Universitas Pajajaran. I was here like 15 years ago, probably. And I will make a presentation about Tangkuban Perahu now. Is it ready? Okay. So I will make a presentation about Tangkuban Perahu. It's about outcrop to subvolcanic hydrothermal system. So subvolcanic hydrothermal system is my personal research, my personal interest, my personal research interest. So Tangkuban Perahu, and the photo is from the previous researcher of Tangkuban Perahu named Pak Nugraha Kartadinata. He works for CVGHM, but probably he's now already retired. Then our work mostly collaboration between BRIN, Akita University, and Universitas Pajajaran. Next part. So the regional geology of Tangkuban Perahu is a part of Sumatra volcanic system in West Java. As Professor Lai already mentioned before, it's a part of a rear arc volcanoes, and you see here beside the Tangkuban Perahu we can get Tampomas volcano, and this is the geological map of Tangkuban Perahu. Is consists of pyroclastics, lava, and many others, tephra and pumice ignimbrite. So next. So when we look at the surface expressions of Tangkuban Perahu at the summit, it's all regularly modified from the volcanic activity. As you see here, you can see the Ratu crater at the bigger part, and then you see 1928 eruption. And when we look at in our era, we can get 2013 and 2019 eruption. So when you look at the crater, inside the crater, mostly is already modified. So yeah, next. and look at the stratigraphy. And we look at the stratigraphy, the development of the stratigraphy is very low. You see, in 1973, the stratigraphy divided into only 5 formation. And then Sutoyo Hadisantoro 1972 divided only 4 formation. And when we look at Kartanineta et al. 2002, we can really get very more specific stratigraphy in Tangkuban Perahu volcano. So my research project mostly is related with the young Tangkuban Perahu, which mostly what you call that one? Related with the subduction, related with the subvolcanic hydrothermal system. See here, when we look at the stratigraphy, the start of the Tangkuban Perahu development mostly magmatic eruption, and then afterwards, when we have a young Tangkuban Perahu formation, we have mostly phreatic and phreatomagmatic eruption. Next. So this is the outcrop. We look at the outcrop, it's very different from magmatic eruption outcrop. You look at the phreatic and phreatomagmatic eruption, you can very see you cannot see pumice, you cannot see scoria. You only see the eruption product is only 1.5 kilometers radius from the crater, and then the characteristics is mostly clayey, whitish bluish color, wet. Some are oxidized and fully hydrothermally altered minerals, and some part you can see charcoal. Because the temperature is, when the emplacement of the volcanic products probably 400 degrees Celsius. Next. So this is what we did, what I did during my PhD. I do my stratigraphic analysis. So we make a correlation, and then we make a composite stratigraphy, and you can see this is the volcanic ash from the eruption, the phreatic eruption. There consists of crystal, free crystal of quartz. There consists of hydrothermally altered. They consist of glass, volcanic glass, and also scoria. The things is, when I do my PhD in Tangkuban Perahu, is there any magmatic eruption during the young era of Tangkuban Perahu? Because that's the question of my research, because you can see magmatic juvenile, you can see scoria, then it's not only related with subvolcanic hydrothermal system, but probably volcanic hydrothermal system also made an interaction with the magmatic system in the Tangkuban Perahu. Next. So we look at the outcrops from phreatic and phreatomagmatic eruption, and we look at, this is what we did with ITB, Institut Teknologi Bandung. We make stratigraphy correlations and stratigraphy analysis for the volcanic products from magmatic eruption. You can see there is only pumice and scoria, and you have pyroclastic flow, mainly pyroclastic flow, mainly pyroclastic fall consists of pumice and scoria, which is very different from what we found in Tangkuban Perahu. Next. Then we look at our mineralogy. This is the composite stratigraphy of Tangkuban Perahu, and the age of this section is a Holocene. So it's Holocene volcanic product. So you see the mineralogy mainly consists of quartz, cristobalite, tridymite, alunite. And when we look at the magmatic minerals, it consists of plagioclase, sandindine, augite, and some felsic minerals
on the upper part of tephra unit 6 and unit to unit 4, there is orthopyroxene. And when you look at on top of the stratigraphy, we can see jarosite, which is very interesting for me because there is no, we haven't found jarosite in Tangkuban Perahu before. This is probably the first time. And jarosite mainly is an oxidation mineral, which is associated with reddish brown volcanic products. Next. Well, then we look at the textures. Okay, when we have silica alteration, at the first time we have pseudomorphic textures. We have plagioclase, which is already replaced by silica. At the first time, this is backscattered image electron. So when you look at this image, then you see about the atomic number. When you have a lighter atomic number, probably black and to gray, and then you have a higher atomic number, it will be bright. So this is, at the first time, we don't really know. We don't really know whether it's what species of silica is it. So we use EDS, and we calculate with atom formula unit, and we got to replace silica. And then afterwards, to check what species is it, we use a Raman spectroscopy, and we got cristobalite and opal. So mainly the magmatic minerals, plagioclase and clinopyroxene, replaced by cristobalite and opal. And next. And then afterwards we look at the quartz alunite. We have a lot of textures of quartz alunite. We have the alunite replaced by sanidine. We have the veinlate of alunite consists of kaolinite and APS, aluminum phosphate sulfate, and the phenolate mostly 1 millimeter in size. And we see here there is a veinlate alunite here, which is overprinting by the quartz pyrite vein. Next. And there is also the alunite as well. We have natural alunite, we have calcium alunite, which is hungite, but the mostly of alunite is potassium alunite, because it's mostly maybe is related with the magmatic gas below the Tangkuban Perahu. Next. And this is the textures of alunite, which is very important for us because we can see the equilibrium condition between alunite and pyrite when we interpret that jarosite oxidized from pyrite. Next. And also we have ore minerals, which is related to, associated with quartz crystals. The ore minerals mainly chalcopyrite and anergite. Next. And we look at the newest eruption, 2019 eruption. What we have here, this is the volcanic product we sampled from Upas crater in 2020. So we have the fine ash, coarse ash, at least 5 layers of eruptions during the series of eruption from July to August. And the main things is we have abundance of pyrite, which is very interesting because pyrite is really hard to find in the Holocene volcanic products. Next. This is the mineralogy. When we have we try to sieve all this ash, and the smaller ash contain much more alunite than the coarse one, which is implies that probably the alunite have smaller crystals, and we need to check it with the SEM. And we have pyrite, which is associated with quartz and alunite as well. Next. Well, this is the textures from petrography. You have mosaic quartz, you have very fine grained quartz, you have pseudomorphic textures of pyrite, of plagioclase replaced by cristobalite and opals, and you have alunite as well. Next. And we check the textures of alunite. Mostly is natural alunite. It's associated with pyrite, and its equilibrium condition during the subvolcanic hydrothermal in a volcanic hydrothermal system, as well as cristobalite. And we have pyrite, which is very cubic facet as well, but you have chromium spinel inside of the pyrite. So there is two types of pyrite in the Tangkuban Perahu volcano in 2019 eruption. That's still be researched. Next. When we look at the temperature, so we need to have a reference for that. So when we have cristobalite and opal is probably 100 to 150 degrees Celsius, and quartz kaolinite it to 160 degrees Celsius. The problem is there is no pyrophyllite, so the temperature is mostly must be lower than 250 degrees Celsius. But you have aluminum phosphate, which is the temperature range from 250 to 300. So then it's quite difficult to understand this temperature of subvolcanic hydrothermal system during the eruption. Then we look at the sulfur isotope. Probably we can get the answer from the sulfur isotope. Next. So we measure sulfur isotopes during that time, and we get a temperature of 200 degree. Well, this is assuming that we have SO2 disproportionation. Probably probably many not really believe with the SO2 disproportionation, but this is assuming that pyrite and alunite is equilibrium and SO2 disproportionation happens. Then we can calculate the temperature is about 230 degrees Celsius at 240 degrees Celsius. Next. So what happened during the eruption? We have three types of eruptions probably happen in Tangkuban Perahu. The first one is probably the hydrothermal eruption. No magmatic input during the eruption. The second one, there is a magmatic input in the subvolcanic hydrothermal system. Then the subvolcanic hydrothermal system is try to equilibrate it, and then eruption happen. The third one, there is probably lava on the crater conduit that keep the gas of magmatic keep the magmatic gas below. Then the eruption happen. This is the three types of our choice, which is related with the steam eruption. Next. When we look at the mineralogy, we don't know whether there is a potassic alteration inside, but the thing is, when we look at the surface of the topography, surface topography of the Tangkuban Perahu, we can see there is the quartz alunite, steam heated alteration, quartz kaolinite, then which mostly related with the which associated probably with the high sulfidation system. So probably what we see in the Tangkuban Perahu is the analog of the hydrothermal high sulfidation system in the fossil ore deposit. Next. Well, in summary, typically the mineral assemblage of Tangkuban Perahu is as a sulfide and as phanerozoic alteration with the temperature of 200 to 240 degrees Celsius. Well, when the mineralogy of 2019 eruption is identical with the Holocene volcanic products, probably then it implies that probably the eruption happens in the Holocene volcanic during the Holocene is similar with the 2019 eruption. The sulfur isotope occurrence of jarosite indicate that jarosite probably oxidized from pyrite. Oxidized of pyrite, which is probably related with the atmospheric oxygen entrainment to oxidize pyrite to jarosite. All minerals represent the upper level of a high sulfidation system, where the stratigraphy of sulfur isotope variation probably related with the influx of magmatic gas into the hydrothermal system, and the sulfur isotope signature very important to evaluate the conditions of volcanic hydrothermal system, which is probably the interaction between magmatic gas and the volcanic hydrothermal system. Next, our future works, we would like to look at the sulfur isotope signature of 2019 eruption. Then we can calculate the sulfide geothermometer. Now we're looking at the Dieng volcanoes, sea layer crater, in collaboration with Akita University and with Universitas Pajajaran. We use a multivariate analysis for morphology textures of volcanic ash that associated with the volcanic hydrothermal system. And the last one, we aim to look at the anatomy of a high sulfidation hydrothermal system at North Sumatra. Probably next month. So thank you very much.
Thank you. Thank you, Mr. Sareza, for your interesting feature of Tangkuban Perahu. So all students, audience, we have heard all of the 4 presenters in front, and maybe now we can go to the Q&A discussion. And maybe there are several audience online already gave, but in the meantime, can I please introduce our presenters, Professor Lai, Wu, Rinaldi, and Mr. Sareza, to sit in front, and hopefully someone will give who wants to share or some questions to these honorable speakers. Please. You can ask anything. You can ask about plate tectonics. You can ask about volcanoes. You can ask about one nearest volcano to our location. And maybe one question about the Ciletuh characterization. Silakan. Silakan angkat tangan. Apa aja? Ada yang mau bertanya? It's okay. You can ask anything. Silakan. Raise your hand. Ada yang online? Ada pertanyaan? Ya, kita sambil nunggu ya. While we wait for you guys to ask anything about what has been presented, maybe Mas Haryo can show us the question from our online audience. Bapak Ibu yang hadir secara online in our Zoom meeting, okay? Langsung aja saya bacakan aja. Okay, this is some questions from the online audience. The question is, what about the Palu Koro Fault in Sulawesi? Will it separate the island of Sulawesi? And what would be the impact on economic mineral or oil processes? From Wahyudi Agus. Maybe about tectonics, maybe Professor Wu or Professor Lai would like to answer these questions. Mas Aryo ada gambar Sulawesi nggak ya? Soalnya ini pertanyaannya. So we do have a active vault at Sulawesi. At Sulawesi, most recently, yeah, maybe at 2-3 years ago, there was quite a big earthquake and the Koro fault. So the question is, will it eventually separate the Sulawesi Island, west and east? A simulation.
So, yeah, so to be honest, I don't really like familiar with the fault, but I just learned from you saying it's a transform fault, and actually I do have some other cases of transform fault that was causing by the oblique subduction. So by oblique subduction, it means that the downgoing plate, the subducting oceanic plate, is not subducting directly to the overriding plate. Instead, it has this low angle subduction, so it's kind of more like a transform boundary. Or say it has a lot of like transform, factors. So one example is in Western U.S., which is the I forgot the San Andreas fault. Yes, and San Andreas fault. So what happens there is that it doesn't really. It actually makes, or say that oblique subduction did make somehow the overriding plate develop this transform fault system, but in the end, it not really make the whole Baja California, separate from the continent. No, but it do have this transform system that kind of moved the like this whole block away from its original location. But on the other hand, I also do have this story also in the Western U.S. is that people found that a lot of terrains in northern U.S. all the way in Alaska. And they were saying that potentially some of the terrain in Alaska, which is further to the north, like 55 or even like higher latitude to the north, like some people saying that it could be came from the California region, and therefore some people call this scenario called, or say hypothesis called the Baja California hypothesis. It means that the terrain had been transformed all the way from south to north for like 3,000 kilometers ish. So I mean, if I would say in that case, or some people would believe that if this transform fault can continue for a much longer geologic time, then it can separate from the plot of the block from its original location.
Thank you, Professor Wu. Any other additional from Professor Lai? Would you give? Okay, so Mr. Agus, maybe you're online, so I think we both understand as geologists, right? Maybe eventually it will separate, but in geological time, not in our time. I'm pretty much sure. So that's if we have a moving rate 1-2 centimeters per year, it means it's going to take a long time. So don't worry about it. I think he's a geologist working in Sulawesi and he's afraid that something happens. He's a nickel explorationist. Okay, Mas Hari masih ada? Oke, ya silakan online, silakan. There are some, we do still have some times. Saya persilakan kepada Bapak Ibu audience online that would like to give some questions to the speakers.
Pak Yoga, please.
Maybe we can share it in the screen so they can ask directly to the speakers.
Can I ask directly to the presenters, please? Pak Yoga. Can you?
Profesor Hananto, selamat siang. Ini.
Siang, Pak.
Prof, silakan, Prof. Silakan.
Ya,
Please state your questions to designated speakers. Silakan, Prof.
Okay. Yeah. Is it I speak in Indonesia or English? I would like to ask to the Indonesian presenters, Yeah, and Mr. I saw some its information in Ciletuh is much younger than precious such structure, yeah, Meratus. Is it necessary to change the name of the structure? Younger result than expected. That is one thing that's near. Do you have any something like fiction? Is it your research? How many years in the future that this maybe some your research? Thank you.
Thank you, Prof. Agak putus-putus, tapi if I'm not mistaken, Professor Hananto, you're asking about these features about the dating in Ciletuh area, and it is related to the suture, yeah, the Java suture. I don't know, and then also connected with Tangkuban Perahu nggak, Sareza barusan, Prof? Nanyanya enggak ya? Jadi mungkin it's about Ciletuh, ya. Rinaldi mungkin bisa jawab, because Prof, Mr. Rinaldi already stated that not some problems, but some issue we have in Ciletuh and Sodong area is that we don't have the exact date. So it's hard to try to figure out which one comes first. But maybe, Mr. Rinaldi, you can answer Prof. Hananto's question.
Yeah, thank you for Prof. Hananto. Apa kabar Prof. Hananto? So
Baik.
I work with him in Sabang, at Sabang Island. So I hope Prof. Hananto is doing well. So to answer that, so yeah, Ciletuh, yeah, we found different age of Ciletuh, but now, yeah, that state that we cannot decide for each units of lithology which one come first, or yeah, we need more geochronologic data. But for now, we have a lack of geochronological data. What we have is the potassium argon from some researcher that state that Ciletuh is younger, which is Eocene in age, around 50 to 56 million years, not like older Cretaceous such as Karang Sambung, for example, more than 80 million years. But here in Ciletuh, yeah, we have that range of 50 to 55. Yeah, the updated uranium lead data, zircon, from zircon. Yeah, we have range of 57 to 70 million years, which is, yeah, back to Cretaceous. So based on that research, so yeah, we can consider that Ciletuh form with almost same range with other melange or Cretaceous suture zones. But based on that, also we still expect that Ciletuh is still younger than Karang Sambung and Meratus. Yeah, that's my answer.
Okay, Professor Hananto, I think Mr. Rinaldi already answered your question, but if it's not that clear, because we also didn't hear very clear, maybe you can connect with Mr. Rinaldi. Mas Aryo, masih ada yang online? We do have several minutes before the speaker asks each other some questions.
Pak Yoga, I have a question. Pak Yoga, I have a question.
Silakan. Oh ya, Pak Wang, silakan. Silakan, Pak Wang.
Pak Yoga, I have. Is my voice clear?
Quite clear. It's clear.
Okay, thank you.
Please.
I have two questions for Professor Lai and for Kang Rinaldi. The first question is to Professor Lai. You mentioned that we have mid-Miocene volcanics migration in westernmost of Sundaland, which is in Sumatra. And you say that because induced by the collisions of India with the Eurasia. My question is, the start of the collision between India and Eurasia was in Eocene. And as we know, after the collision, usually the subductions will cease. So there is not any partial melting that will feeding the volcanism. So why you mentioned that, or you consider that the collisions of India to Eurasia making the migrations of volcanics in Miocene in Sumatra? Is it because of partial melting of subduction zone? Because in mid-Miocene we don't have any subduction zone or subducted slab, yeah, in India to Eurasia because of collision since in Eocene, or the mechanisms in the mechanism the collision trigger the strike slip, the strike slips that more to the northeast in Sumatra. But the question is why you seek for the mechanisms to the Eurasia and India collisions, not to the oblique subductions in to the west of Sumatra. So that is the questions for Professor Lai. Please answer first before I go to the Kang Rinaldi.
Okay. According to the question, I just thinking about the subduction between Sumatra from the southern part to the northern part is changed from the normal subduction to oblique subduction, and why I find the most western part of Sumatra stopped by the change from subduction, oblique subduction to like transform motion. That is because from the dating result, in the southern part, the most west part of the Sumatra in the southern volcanism just we just find the volcanism start from about 20 or something MA. It's just in during the Miocene, but actually we still have older than that one. So I don't discuss about the older volcanism. Just talking about the transform from the southern to the northern. The time maybe start from the late Miocene. So in the northern part of the Sumatra fault, all of the volcano, not two major volcano complex is very young. So that's why I just say maybe this is caused by the magma migration, and the effect is the large tectonic things from the Indian collection and the migration from the Burma to this area. So that's what I'm thinking about.
Okay, I will read your paper for a more elaborative answer. So the next question is to Kang Rinaldi. Kang Rinaldi, could you display the pseudo-stratigraphic of the Cilatu, please? Could you display this the pseudo-stratigraphic of Cilatu of your light Cilatu, please?
Okay. Okay, but okay, thank you, Pak Awang, for pseudostratigraphic.
Yeah, sorry. If possible, could you display the Cilatu stratigraphic first?
Can I show the presentation?
Yeah. I need the stratigraphy of your light. Thank you.
So next to, I think slides number, next, yeah.
Yeah,
that
yeah,
one.
here. Thank you.
Pak Awang?
Yeah, the question says, no,
Is
my
the-
question, Pak Renaldi, the question says,
The slides, can
do
we
you
see?
find the pillow basalt now? Because initially we think that pillow basalt in Pulau Kunti or in Gunung Badak is part of the uppermost part of Ciletuh of ophiolite, but the dating from Pak Adi Hardiono show that the age is 22 million years ago. So this is part of the Jampang volcanics. So actually we don't know now for sure about the presence of the pillow basalt as a part of the ophiolite. Do you find new thing about this?
Yeah, Pak Awang, thank you. The answer is for pillow basalts, especially no. There's no new findings about this. Here I mentioned about the pillow, but I mentioned about metabasalts. So we consider that. Yeah, the question is where is the upper part of crustal section in Ciletuh? Because we only found the mantle section and the not incomplete part of the crustal. So there for metabasalts means the not the paleo-lava one that we know. That's the but we have the basalt protolith in our greensis and amphibolites samples. So we interpreted the metamorphic rocks such as greensis and amphibolites could become the basalt origin. So here is the metabasalt. So means the upper part of the crust has already undergone metamorphism. That's the answer, Pak.
Okay.
For now, we haven't found the updated data for basalt in Ciletuh.
Okay, thank you. Could we go to the?
Terima kasih,
the
Bang
person,
Rinaldi.
Yoga?
Semoga
I have another
menjawab
questions.
Pak Awang. Kalau enggak nanti kita diskusi lagi langsung
Okay, thank
dihubungi Rinaldinya Pak Awang.
Yes, thank you.
Mas Arya masih ada yang online? Ada ya? We do have several minutes before.
Ya. Saya Prof. Yoga.
Siap. Silakan.
Ya, terima kasih. Thank you. Before my question, allow me to introduce myself. My name Nur Cahyo, as a coordinator of group research of marine geology. That's why I would like to question to Mr. Professor Wu and Jeremy from the Taiwan, from the Normal University. That my question is, based on your observation on land phenomena tectonic, could you the volcanic front of offset between southern Sumatra and western Java be explained by slab tear or segmentation beneath the Sunda Strait, or maybe what you expected when you found the geological phenomena, the subsurface Sunda Strait? Hello?
So to be honest, because I'm not quite familiar with the Java's magmatism and also the slab beneath. I all learned from Dr. Lai, but I couldn't really like answer the question directly. But having said that, I feel like Dr. Lai, one of Dr. Lai's slides had already have some hint maybe. Like maybe the couple last one, like showing there's a slab window that is open right there,
Yeah.
which was actually from seismic tomography, made by Huang et al. Yeah. So it can be like that. I will tend to link to some of the magmatic hiatus to the slab window, and it is because if you go back to the say like the typical way that we have arc magmatism, which is from the fluid that was introduced by the downgoing slab. And it means that you need to have those slab in the depths that has the dehydration metamorphism, so we can have the the hydration, or say the fluid, come out. So in the slab window case, it can be saying that there's no slab in that range of dehydration metamorphism, and therefore there will be no fluid being introduced into the mantle wedge. So in that case, that could cause a magmatic hiatus. So that's just what I've learned from Northeast Asia. But I wonder, Dr. Lai could have some more comments on it.
Okay, I think Professor Lai also has the same comments with Professor Wu. Sebelum kita ke audiens lagi, tadi ada pesan Professor Lai. Do you have some questions to? Yes, before.
Yeah. Yeah, it's a very good study for the Takaban Huahu, and especially for the volcanology. So my question is, you're talking about you find the minerals is about included like quartz, crystal pyrite, tremendite, and the others, and also talk about maybe the model will be like a phreatic eruption or how to say hydrothermal eruption. So it means if the phreatic eruption we suppose will not have the juvenile class to involve, right? So my first question is, when you see the outcrop, you can when you see the outcrop layers, you can find also the juvenile class. So maybe it's not only one model. Maybe they combine each part of them. So that is the suggestion. And another question is, you find the tredamine, crystal pyrite, and quartz at the same time. So it means we know some of them is like the high pressure minerals. Some is the high temperature minerals. So why they exist at the same time? If you have any implication for that?
Yes, thank you very much, Professor Lai. For the first question, yes, because we look through all the minerals in the Holocene volcanic products, so there is some part of the event that happens to be more phreatomagmatic or magmatic hydrothermal eruption, which may be consist of magmatic juvenile in the volcanic products, but mainly on most of the Holocene volcanic product, there is only they're mostly phreatic and hydrothermal phreatic eruption. That's the thing for the question number one. But the question number two, I also don't know how it's happened. Why tridymite is a very high temperature and high pressure minerals happen to be similar as the same with the cristobalite and quartz. And the thing is, when we look at the cristobalite, it's probably low temperature because this replaced the plagioclase. But the tridymite, I couldn't find any tridymite in the samples, so I couldn't answer that one. Yes.
Yeah, because for cristobalite we can understand maybe they have two types, the high temperature and the lower one. And lower one can be happen by the hydrothermal alteration, so it's doable. But cristobalite is strange.
Thank you, Pak Lenda. Habis? Masih ada? Maybe one more because of the time. Okay. This one, I think we already answered that one. What makes lithology uncomfort? Subduction, as we can see in this presentation, we could see in mantle peridotite heterogeneity. And then there's a question to Pak Reza. Since when have the eruption of Tacubán Parahu volcano been phreatic in nature? And have there ever been phreatomagmatic eruption? And is the magma source for Ratu crater same with the Domas crater? From Pak Heriadi. And maybe Pak Nur Cahyo tadi udah ya, Mas Arya, dah. Mungkin itu aja Pak Reza, mungkin the last but not the least dari Pak Heriadi.
Terima kasih Pak Heriadi. Thank you very much Pak Heriadi. This is question very intriguing. I haven't researched about Domas crater at all, so I couldn't answer that the sulfur from Domas is related with the magmatic gas, or whether it's related with the more hydrothermal system. But the thing is, probably the water table at Tangkuban Perahu is flat at the Domas crater. It's related with the hydrothermal system rather than in magmatic gas. So that's my answer probably. Hopefully it will be answered your question.
Thank you very much. A round of applause everyone for all of the speakers. Sekali lagi terima kasih. Professor Lai and Professor Wu and the team from BRIN just came back from the field, and we are very fortunate to have them with us. So I hope all of the questions and all of the answers and all of the presentation that have been held this morning can make a broader sense about volcanology and magmatism, especially in our region and Southeast Asia and also in Taiwan. I would like to thank you, Professor Lai, Professor Wu, Pak Rinaldi, dan Kang Reza for giving a wonderful presentation and gives us a more understanding about Indonesia as a subduction zone, things like that. So again, a round of applause for all of the speakers, everyone. Saya kembalikan lagi ke Ibu.
Thank you very much, Dr. Sains Yoga Andriana Sanjaya, for guiding our main session. And thank you very much to the speakers, Professor Jeremy Sung Juiwu, Professor Yu Ming Lai, Dr. Shahreja Saidina Angkasa, and Dr. Sains Rinaldi Irkam. And now, ladies and gentlemen, Mr. Youngmi would like to present a souvenir to Mr. Yoga, our moderator. May I invite them to the stage? Okay, let us give applause. Thank you very much. Ladies and gentlemen, we have now reached the end of DiGDaya 25th edition and FTG Studium Generale. On behalf of the Faculty of Geological Engineering, Universitas Pajajaran, and the National Research and Innovation Agency BRIN, we express our deepest gratitude to our leadership speakers, guests, and every participant who contributed to make this collaboration a highly successful and fruitful scientific forum. We hope that the knowledge education and partnership established today will further advance our shared horizon in geological engineering and scientific innovation. Ladies and gentlemen, have a wonderful afternoon ahead. Stay safe and stay inspired. Wassalamualaikum warahmatullahi wabarakatuh.